In this plane problem, we have a plane moving at 700 miles per hour, 54 degrees east of north. We have wind blowing 32 degrees west of north at 128 miles per hour. So what we can do is split these two vectors up into their component vectors. This plane is going east and it's going north. So its horizontal vector is pointing east and its vertical vector is pointing north. The wind is blowing west, so it's pointing west and it's pointing north. So first thing we notice is that they both want to go north, but they want to go opposite directions, east and west. So we need to first split this up into its component vectors. And the first thing is just based on how I drew this picture. Some people may have done this differently, but how I drew it, I need to know that this angle is 36 degrees and that this angle is 58 degrees. So then using basic right triangle trig, I can say that this is 700 times cosine of 36 degrees, and this is 700 times sine of 36 degrees. And then similarly over here we have 128 times cosine of 58, and we have 128 times sine of 58. Those are our two component vectors, or those are the component vectors of the two colliding plane and wind vectors. So when they collide, their vertical components and their horizontal components are going to combine. And since their vertical components are pointing in the same direction, they both want to go north, we're just going to add those. So we get 128, let's do 700 first, 700 sine 36 plus 128 sine 58. And then we're going to get 700 cosine 36 minus 128 cosine of 58. So those are going to combine to be, this one's going to represent about 520 miles per hour, and this one's going to represent about 498.5 miles per hour. Our new vertical and horizontal components. Now if you look at this, the plane isn't going to get blown so off course that it's no longer going east. It's still going to be going east. Its horizontal component is bigger than the wind's. So we're still going to go east, and we're definitely going to be going north. So, and that can actually be seen if we actually shift this wind vector over and see what happens when they collide. Here's the wind vector. All right, so when they collide, it's going to look like this. I'm going to do a green line to see what happens. Okay, the plane gets pushed up, so it's now closer to north than it was before, and it's going to be going a little bit faster, and that's what we're figuring out. So we have the new component vectors of this new green vector. We just found them. So let's draw a new triangle down here. There's our new plane vector. And then this is our 498.5, and then this is our 520. 520. So then if we Pythag this, we're going to get our new magnitude. So it's the 520 squared plus 498.5 squared, and that's equal to 720.35 mph. So the plane is now going about 20 miles per hour faster than it was going initially because of this wind, but it's also going to have a changed angle. So if we look at the angle we're looking for, which is this one, we're going to arctan this. If we arctan opposite over adjacent, 520 over 498.5, we're going to get an angle of 43.8 degrees. So that's this angle. But if we think about how far away from north we are, we're not 43.8 degrees away from north. If we were to draw north, it would look like that, and we'd actually be looking for this angle. Again, if we go up here, right? We're not looking for this angle, we're looking for that angle. So we're going to do 90 minus 43.8 in this case, which we don't always have to do. You just have to look at your picture and figure it out. But in this case, we have to do this. 90 minus 43.8 is actually 46.2. So we have a final answer now. We have that our plane is moving at a bearing of, it's 46.2 degrees west of north now. And, or sorry, east of north, not west of north, east of north. Whereas before, it was 54 degrees east of north, and now it's closer because the wind pushed it up a little bit. So now it's only 46.2 degrees west of north, and it's moving at about 720, what was it, 720.35 miles per hour. That's your final answer.